Hello everyone. Have you ever wondered how a phone can recognize your face, how a car can drive itself, or how YouTube or Netflix understand what you're going to watch next? So the answer lies in something called neural network. They are basically the digital brain of modern AI. In this video, I'm going to explain what exactly neural networks are, how they learn, and why they're so powerful in plain and simple language. Let's go into it.
Hey everyone, welcome back to the channel. So far we've talked about the history of AI, then data, then machine learning, and in the last video we touched on deep learning. But here's the big question, what is actually inside deep learning and what makes it work? Well, at the heart of it is something called a neural network, the architecture that you see here, and that's exactly what we're going to break down today. So I know there's a lot of math involved, but I try to keep things simple for the purpose of this video. Let's jump in to see what a neuron is. So everything starts with a single unit called a neuron. Think of a neuron like a tiny decision maker. So it takes some input, the set of input that I've denoted them with the x, starting from xa all the way to xn. Then it processes them at the heart of the neuron, and then it produces an output. Note that here every input is having an associated weight with it, which is also called importance, that I've denoted with a set of w starting from w1 all the way to wn. So if I explain this process inside a neuron mathematically is nothing but a multiplication of an input with its associated weight, and these are all sum up plus a bias term. And then the result, which you see y, is not actually the final result of the neuron. So this y is nothing but the addition of all the dot products of the input in its respective weight. So this y will then be passed through a rule called an activation function. So there are different activation function depending on the type of output that it would produce. So the most important ones are listed here. The one is called sigmoid and then tanh in ReLU, also known as rectified linear unit, which is the most popular today. And it's also simple and it works very well in practice. So what a ReLU function is doing, it's producing an output that is exactly the input itself if it is positive, and otherwise if the input to the ReLU function is not positive, then it just produces 0. So at the end, what happened is the neuron spit out a decision, maybe a yes, maybe a no, or maybe even a probability. So you saw that the neuron is taking an input, process that, and then produce an output. But one neuron by itself is pretty limited by its computation power. But when we connect many neurons together, we get a very powerful architecture, and that is called a layer, as you can see in this diagram. So we have three main types of layers in the neural network. We have the input layer, which takes the raw data, and then we have the hidden layer, which is actually the middle layer, and they are doing a very complex task, like maybe finding patterns in relationship in data points, among data points. And then we have the output layer, which is giving you the final answer. For example, if this network is for the task of image classification, the output layer might give you a probability, for example, a 0.75% probability that this picture is a picture of a cat, for example. Or if this network is designed to do the handwritten digit classification, maybe this network in the output layer is giving you a 90% probability that this digit that you've shown to the model, to the network, is a 5 or 7 or so on and so forth. So each layer actually builds on the one before it. So the input from the previous layer is passed, the output from the previous layer is passed as an input to the next layer. And as we move forward from the input layer to deeper and deeper layer in the network is getting smarter step by step. So now we are going to talk about training a network. So training a network includes several steps starting from the forward pass and then calculating the loss with the help of a loss function and then a backpropagation, which allowed the network to backpropagate the loss or the difference between the y actual and y predicted. And then the optimization steps, which allows the network to adjust the weight so that the network will make a smaller error on the next try. And then the repetition step. I'm just going to give you a simple explanation about every individual steps here, and then we move on to the next step. So in the forward pass, what we're going to do is we feed in data to the model. Say, for example, we feed an image of a number 5 to the model, and then it passed all the way to the output layer of this network. And let's say the network is making a prediction of 7. So the network says the number or the image of the number that you have passed to me is probably 7, because which is normal because the network is not yet that knowledgeable to understand the difference between the different categories of numbers. And that's when the next step comes into play, which is using a loss function to calculate the difference between the y actual and y predicted. That's nothing but the loss or the error. So there are different loss functions that we can use. The one we generally use for the task of, for example, predicting a number is an error function called MSE, or mean squared error. Well, there are plenty of other errors as well, depending on the sort of application or the problems that you are solving with the network. You will decide the loss function as well. And then once we have found the loss, we have to backpropagate that loss to the different layers of the network, to the different neurons, so that every individual neuron should get a understanding of how much are they contributing to this error, and how should they change next time so that they reduce the amount of error or the difference between the y actual and y predicted. That's when the optimization step comes into play. So this is actually the step that we are going to update the weights of individual neuron. So one of the algorithms that are used in optimization step is called gradient descent. It's like walking down a foggy hill step by step until we reach to the bottom or to the lowest error, which is like the main goal of optimization function, that we have to reduce the error. So there are a smarter version of gradient descent as well. They are stochastic gradient descent, which is faster, which works in smaller batches, and also atom optimizer, which is the most popular today. And it actually automatically adjusts how big each step should be. And then the final step, which is the repetition step. So this whole process of predicting, checking the error or the difference between the y actual and y predicted, and then backpropagating the error to the network, to the different layers, and adjusting the weight will happen thousands or even millions of times until the network gets really good at the task that it is designed for. Now we are going to talk about the applications of neural network. So neural networks are everywhere. It's just that we are not going to see them. So I'm just going to give you a few examples, and then you will see how these neural networks are sort of embedded into our daily life without even us realizing that. So when you lock and unlock your phone with your face or finger, underneath that there is a neural network. to do the task of classification of your image or your fingerprint. Or when you're using Netflix or Spotify or YouTube, so there is a powerful recommendation system in those application that would recommend you the next movie that you have to watch or the next music that you have to listen to. So this is all powered by a neural network that is specifically trained for that task. Or Siri and Alexa, for example, when they are understanding your voice command. So when you talk to your iPhone, especially with the Siri voice assistant, you just send command to the Siri, and Siri just listen to you and do the task that you're asking it. So when when a command is successfully executed in the Siri is able to do the task that you have asked Siri to do, it simply means that it has a knowledge of understanding your natural language, and that's nothing but the power of neural network underneath. Or the self-driving car, for example, that they are able to commute safely around the city without making an accident or without taking someone down. So this is also an application of a neural network. Note that for every task that we employ a network, we first need to have a good data set for that task. Then we have to choose a specialized network for that task. Otherwise, it's not going to give you the result that you are expecting. All right, to conclude our video, so we started with a single neuron, then we talked about layers, then we also talked about how different layers are stacking together to form a more complex network. Then we also talked about training a neural network with the help of the loss function and optimization function. And finally, I give you some real-world application of a neural network. So in the next videos, we'll be looking into more specialized networks like CNN for images, RNN for sequential data, and of course, transformers, which powers the current models underneath the beloved application of ChatGPT.
Thanks for watching my video to the end. I hope you have got a foundational knowledge on neural network. If you found my video useful, please like it and consider subscribing to my channel. I am looking forward to see you in the next one.